This is another greatest and least values problem, but this time I've got a cubic function, and obviously our cubic functions look like this, or they potentially look like this. Honestly, I don't know what this one looks like. I can't remember. So if it's one that looks like this, we're going to have two stationary points, and we're going to have those boundary points as well. So we'll have to pick between these ones to see which one is the greatest and least value. If it looks like this, we can pretty much know straight away that our boundary points are going to be our greatest and least, because our stationary point of inflection, it doesn't matter what it is, it's always going to be in the middle. But we'll see. This is as much a learning experience for me as it is for you. I'm kidding, I totally know what I'm doing. Alright, so first things first, when we are finding our stationary points, we need to derive this function. So if f of x is equal to x cubed plus 9, f dash x is going to be 3 times 1, which is 2, x, 3 take 1 is, what the hell, no, 3 times 1 is 3, soz bro, and then x, 3 take 1 is 2, that's where I was getting confused, and then the 9 disappears because there's no x's attached to that, so that's going to be our derivative point, so that's nice. We then make this equal to 0, 3x squared. We can pretty much see from that x is going to be equal to 0. If you can't, work it out, but I promise that's what it is. So this is similar to the last one. There's only one x value, so that kind of tells us that it's probably going to look like this, which means our boundary points are going to be the money makers. But let's just go through the process anyway, just to make sure. So we find a point either side of that x value. So when x is -1, sub that in. 3 times -1 squared equals 3 times 1 equals 3. And then, so that's positive, and then we've got this. When x equals +1, can anyone see where this is going? 3 times 1 squared equals 3 times 1 equals, holy dooly, it's 3. So look, that's also positive. So what we have is a stationary point of inflection, which means that it does look like this. So our boundary points, we can already tell, are going to be our greatest and least values. But we're only given the x values, so we still have to sub them into the equation. Just in the interests of not making the mistake that I made last time, let's make sure that we put this x value back into the original function, just to get our full coordinate. So f of 0 is 0 cubed plus 9 equals 9. So the coordinates of our stationary point of inflection are 0, 9. Wonderful. Now, let's deal with our boundary points. So when x is equal to -2, you know what, if I'd been smarter up here, I could have already done it, but I haven't, because I'm not that smart. F of -2 is equal to -2 cubed plus 9. Oh, this is going to be fun. So -2 cubed. So -2 times -2 is +4. Times by -2 again is -8. So you need to make sure you're really careful with your negative signs when you're dealing with cubes, because when they're squared it becomes positive, but when it's cubed it becomes negative again. So that's -8 plus 9, so that's going to be 1. So our coordinates there are going to be -2, 1, and then when x is equal to +2, which is our other boundary point, yes, thank you, Kat, f of 2 is equal to 2 cubed plus 9, 2 cubed is 8, plus 9 equals 17, so our other point there is 17. So that tells us that our greatest point on this bounded curve is 17, because that's the highest y value we have, and our least point on this bounded curve is 1, because that is the lowest y value that we have. Boom! Done!